Hey, hi everyone, welcome back to this video series on Windows Server 2012. Microsoft MPIO, multiple path IO MPIO is associated with high availability because a computer will be able to use a solution with redundant physical paths connected to a storage device. Thus, if one path fails, an application will continue to run because it can access data across the other path. The MPIO software provides the functionality needed for the computer to take advantage of the redundant storage paths. MPIO solutions can also load balance data traffic across both paths to the storage device, virtually eliminating bandwidth bottlenecks to the computer. What allows MPIO to provide this functionality is the new native Microsoft Device Storage Module, Microsoft DSM. The Microsoft DSM is a driver that communicates with storage devices, iSCSI, Fibre Channel or SAS, and it provides the chosen load balancing policies. Windows Server 2012 R2 supports the following load balancing policies: failover. In a failover configuration, there is no load balancing. There is a primary path that is established for all requests and subsequent standby paths. If the primary path fails, one of the standby paths will be used. Failback. This is similar to failover in that it has primary and standby paths. However, with failback, you designate a preferred path that will handle all process requests until it fails, after which the standby path will become active until the primary reestablishes a connection and automatically regains control. Round robin. In a round robin configuration, all available paths will be active and will be used to distribute an IO in a balanced round robin fashion. Round robin with a subset of paths. In this configuration, a specific set of paths will be designated as a primary set and another as standby paths. All IO will use the primary set of paths in a round robin fashion until all of the sets fail. Only at this time will the standby paths become active. Dynamic least queue depth. In a dynamic least queue depth configuration, IO will route to the path with the least number of outstanding requests, wait path. In a wait path configuration, paths are assigned a number. Wait IO requests will use the path with the least wait. The higher the number, the lower the priority. Exercise 1.7 demonstrates the process of installing the Microsoft MPIO feature for Windows Server 2012. Installing MPIO. 1. Choose a server manager by clicking the server manager icon on the taskbar. 2. Click the number 2, add roles and features. 3. Choose role feature or feature-based installation and click next. 4. Choose your server and click next. 5. Click next on the role screen. 6. On the select feature screen, choose the multipath IO checkbox, click next. 7. On the confirm installation selections page, verify that multipath IO is the feature that will be installed, click install. 8. After the installation completes, the installation results page appears stating that the server must be rebooted to finish the installation process. 9. Click close. 10. Restart the system. Typically, most storage arrays work with the Microsoft DSM. However, some hardware vendors require DSM software that is specific to their products. Third-party DSM software is installed through the MPIO utility as follows. 1. Open Administrative Tools MPIO. 2. Select the DSM Install tab. 3. Add the path of the INF file and click Install. iSCSI. Internet Small Computer System Interface, iSCSI, is an interconnect protocol used to establish and manage a connection between a computer initiator and a storage device target. It does this by using a connection through TCP port 3260, which allows it to be used over a LAN, a WAN, or the internet. Each initiator is identified by its iSCSI qualified name IQN, and it is used to establish its connection to an iSCSI target. iSCSI was developed to allow block level access to a storage device over a network. This is different from using a network attached storage NAS device that connects through the use of a common internet file system, CIFS, or network file system, NFS. Block level access is important to many applications that require direct access to storage. Microsoft Exchange and Microsoft SQL are examples of applications that require direct access to storage. By being able to leverage the existing network infrastructure, iSCSI was also developed as an alternative to Fibre Channel storage by alleviating the additional hardware costs associated with Fibre Channel storage solution. iSCSI has another advantage over Fibre Channel in that it can provide security for storage devices. iSCSI can use Challenge Handshake Authentication Protocol, CHAP, or MS-CHAP, for authentication, and Internet Protocol Security, IPsec, for encryption. Windows Server 2012 R2 was able to connect an iSCSI storage device out of the box with no additional software needing to be installed. This is because the Microsoft iSCSI initiator is built into the operating system. Windows Server 2012 R2 supports different ways to initiate a SCSI session. Through the native Microsoft iSCSI software initiator that resides on Windows Server 2012 R2, using both a hardware iSCSI host bus adapter HBA that is installed in the computer. Both the Microsoft iSCSI software initiator and the iSCSI HBA present an iSCSI qualified name that identifies the host initiator. When the Microsoft iSCSI software initiator is used, the CPU utilization may be as much as 30% higher than on a computer with a hardware iSCSI HBA. This is because all of the iSCSI process requests are handled within the operating system. Using a hardware iSCSI HBA, process requests can be offloaded to the adapter, thus freeing the CPU overhead associated with the Microsoft iSCSI software initiator. However, iSCSI HBAs can be expensive, whereas the Microsoft iSCSI software initiator is free. It is worthwhile to install the Microsoft iSCSI software initiator and perform load testing to see how much overhead the computer will have prior to purchasing an iSCSI HB or HBAs. Depending on the redundancy level, exercise 1.8 explains how to install and configure an iSCSI connection. Configuring iSCSI storage connection. 1. Click the Windows key or Start button in the left-hand corner, Administrative Tools, iSCSI Initiator. If a dialog box appears, click Yes to start the service. 3. Click the Discovery tab. 4. In the target portals portion of the page, click Discover Portal. 5. Enter the IP address of the target portal and click OK. 6. The IP address of the target portal appears in the target portals box. 7. Click OK. To use the storage that has now been presented to the server, you must create a volume on it and format the space. Internet Storage Name Service. Internet Storage Name Service, iSNS, allows for central registration of an iSCSI environment because it automatically discovers available targets on the network. The purpose of iSNS is to help find available targets on a large iSCSI network. The Microsoft iSCSI initiator includes an iSNS client that is used to register with the iSNS. The iSNS feature maintains a database of clients that it has registered either through DHCP discovery or through manual registration. iSNS DHCP is available after the installation of the service, and it is used to allow iSNS clients to discover the location of the iSNS. However, if iSNS DHCP is not required, iSNS clients must be registered manually with the iSCSI CLI command. To execute the command, launch a command prompt on a computer hosting the Microsoft iSCSI and type iSCSI CLI add DNS server name, where server name is the name of the computer hosting iSNS. Exercise 1.9 walks through the steps required to install the iSNS feature on a Windows Server 2012 or 2, and then it explains the different tabs in the iSNS. Installing the iSNS feature on Windows Server 2012 or 2. 1. Choose Server Manager by clicking the Server Manager icon on the taskbar. 2. Click number 2, Add Roles and Features. 3. Choose Role-Based Feature or Feature-Based Installation and click Next. 4. Choose your server and click Next. 5. Click Next on the Roles screen. 6. On the Select Feature screen, choose the iSNS Server Service checkbox. Click Next. 7. On the confirmation screen, click the Install button. 8. Click on the Close button, close Server Manager and reboot. 9. Log in and open the iSNS server under Administrative Tools. 10. Click the General tab. This tab displays the list of registered initiators and targets in addition to their iSCSI qualified name. It lists storage node type, target or initiator, alias string, and entity identifier, then fully qualified domain name FQDN of the machine hosting the iSNS client. 11. Click on the Discovery Domains tab. The purpose of the Discovery Domains is to provide a way to separate and group nodes. This is similar to zoning in Fibre Channel. The following options are available on the Discovery Domains tab. Create is used to create a new discovery domain. Refresh is used to repopulate the discovery domain drop-down list. Delete is used to delete the currently selected discovery domain. Add is used to add nodes that are already registered in iSNS to the currently selected discovery domain. Add new is used to add nodes by entering iSCSI qualified name IQN of the node. These nodes do not have to be currently registered. Remove is used to remove selected nodes from the discovery domain. 12. Click the Discovery Domain Sets tab. The purpose of Discovery Domain Sets is to separate further discovery domains. Discovery domains can be enabled or disabled, giving administrators the ability to restrict further the visibility of all initiators and targets. The options of the Discovery Domain Set tab are as follows. The Enable checkbox is used to indicate the status of the discovery domain sets and to turn them off and on. Create is used to create new discovery domain sets. Refresh is used to repopulate the discovery domain sets drop-down list. Delete is used to delete the currently selected discovery domain set. Add is used to add discovery domains to the currently selected discovery domain set. Remove is used to remove selected nodes from the discovery domain sets. Fibre channel. Fibre channel storage devices are similar to iSCSI storage devices in that they both allow block level access to their data sets and can provide MPIO policies with the proper hardware configurations. However, Fibre channel requires a fibre channel HBA, fiber optic cables, and fibre channel switches to connect to a storage device. A worldwide name WWN from the fibre channel HBA is used from the host and the device so that they can communicate directly with each other, similar to using NIC's MAC address. In other words, a logical unit number LUN is presented from a fibre channel storage device to the WWN of the host HBA. Fibre channel has been the preferred method of storage because of the available connection bandwidth between the storage and the host. Fibre channel devices support 1 gig, 2 gig, and 4 gigs connections, and they will soon support 8 gigs connections. But now that 10 gig Ethernet networks are becoming more prevalent in many data centers, iSCSI can be a sustainable alternative. It is important to consider that 10 gig network switches can be more expensive than comparable fibre channel switches. Endport identification virtualization, MPIO, is a fibre channel facility allowing multiple endport IDs to share a single physical endport. This allows multiple fibre channel initiators to copy a single physical port by using a single port. This eases hardware requirements in storage area network SEN design, network attached storage. The concept of network attached storage NAS solution is that it is a low-cost device for storing data and serving files through the use of an Ethernet LAN connection. An NAS device accesses data at the file level via a communication protocol such as NFS, CIFS, or even HTTP, which is different from iSCSI or FC fibre channel storage devices that access the data at the block level. NAS devices are best used in file storing applications, and they do not require a storage expert to install and maintain the device. In most cases, the only setup that is required is an IP address and an Ethernet connection. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.